Hello Year 12s, this is a presentation that I'm making to you on linear coordinate geometry. Now the problems are mainly from 2C, so you could look that up and well have a go at a few of them and see how you go from there. Now I'm going to do a couple of things to these two particular points, so distance will be the first one. Alright, so I want to find the distance between the 2 points. Now the distance formula between 2 points is y2 minus y1 squared plus x2 minus x1 squared. And you can think about that as just, I guess, a sort of a representation of Pythagoras' theorem. So what about if I call this point number 1 and this point number 2? So here's the x-coordinate of point number 1, here's the y-coordinate of point number 1, here's the x-coordinate of point number 2, and here's the y-coordinate of point number 2. Now if I substitute in here, so in place of y1 goes 1, in place of y2 goes 1, in place of y1 goes 7, in place of x2 goes 6, in place of x1 goes minus 2. 1 minus 7 is minus 6, and minus and minus is a plus. 6 plus 2 is 8. Now minus 6 squared is 36. 8 squared is 64. Now when I add them together I'll get 100. So the distance between them is 10. Let's try something else. Now what about this one? What if we change the problem now and we say, okay, well we need to find the midpoint. What's halfway between these 2 points? Well, the midpoint formula is this one here. x1 plus x2 over 2 and y1 plus y2 over 2. So halfway between the x values and halfway between the y values. So there's the x values, so I'll put them in. Minus 2 plus 6 over 2 and 7 plus 1 over 2. So that'll mean 4 over 2 and 8 over 2, which simplifies down to be 2, 4, and that's the midpoint. So halfway between this point here and this point here is this point here. Alrighty, a couple more to go. Okay, well what about if we now have to find the gradient between these 2 points? Now the same sort of thing, here is x1, here's y1, this is point number 1, here is point number 2, and the x-coordinate of point number 2 is 6, and the y-coordinate of point number 2 is 1. So if we go m equals y2 minus y1 over x2 minus x1, we can put that in, so that'll be 1 minus 7 over 6 minus negative 2. Now let's see, that'll be minus 6 over 8, because minus and minus is a plus, and 6 plus 2 is 8. So I could simplify that down to minus 3/4. Righty, almost done. Okay, well what about now? Well, we have to find the last bit here, which is to find the equation between these points. Now the first thing to do is find the gradient. Now we found that previously it was minus 3/4. Now let's just roughly plot each of these points. So there's the x-axis and there's the y-axis. So negative 2, 7 is somewhere up here. And 6, 1 would be somewhere down there. So the equation between these two would go something like that. So that kind of makes sense. It's what? Let's see, minus 2, 7, it would have to be 6 down, minus 6 down, and from negative 2 across to 6, that's 8 across. Okay, so that would make sense that the gradient was minus 3/4. Now we also know that y equals mx plus c, and we know a pair of x and y values, and we know m. So we could say in place of y, let's put in 1, because that's the y coordinate 1 there. In place of m, that's minus 3/4. In place of x we can put in 6, and the only thing we don't know is the intercept, which we'll work out now. So that is 1 equals, let's see, 3/4 of 6 would be, 3 times 6 is 18 over 4, which works out to be, I'll simplify that down, 2, half of that is 9, half of that is 2, so I can see that that'll be, c is equal to 1 plus 2, c is equal to 11 over 2. Okay. So y is equal to, now the gradient would be, if I'm using this model, minus 3/4 x plus 11 over 2. And that's the equation for the line that goes through these 2 points. Alrighty, we'll leave it there for the moment, and I'll see you in class if you have any more problems.